Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Izwan bin Zainal. My supervisor, Professor Dr. Zuhaina Zakaria, and co-supervisor is Dr. Zuhaila bin Yasin. Today I would like to present my paper and title is about optimizing voltage profile and loss minimization using multi-objective Cuckoo search algorithm. This is my story regarding working experience and education. In the distribution system, there are two losses were identified. One is technical losses and the other one is non-technical losses. The technical losses are related with the component of voltage in the distribution system. Any changes of voltage level will affect the losses magnitude. The network reconfiguration is used in distribution system to ensure the voltage profile is within the range between minimum and maximum that recognized. This activity involves the two types of switches, sectionalizing switches and tie-line switches. By changing the normally closed sectionalizing switches and normally open tie-line switches, it will change the source taken from the selected load that will affect the voltage profile. This paper presents the new technique to identify the optimal network reconfiguration using multi-objective Cuckoo search algorithm using IEEE 69 bus radial distribution test system by comparing with the ant lion optimizer. Distribution system is normally designed in radial circuit, whereby every circuit is ready for connecting by changing the topology between sectionalizing switches and tie-line switches. These changes are necessary to fulfill the requirement of needs such as improve voltage profile and reduce the power loss in the distribution system. The voltage profile is changes due to the condition of the components which are connected in the distribution system, such as length of cable, changes of load profile, and inrush current. Any changes of the voltage profile, it will affect the losses magnitude because of changes in current magnitude. The topology changes between sectionalizing switches, which categorized as normally closed switch, and tie-line switches where these switches are categorized as normally open switch. When the tie-line switch is in closed position, the sectionalizing switch must be opposite from the normal position. This situation is complying the concept of radial distribution system. In recent years, many researchers introduced various artificial intelligence approaches to ensure the optimal switches are carried out and satisfy the chosen objective. The artificial intelligence techniques which have been implemented to solve network reconfiguration problem include particle swarm optimization, fireworks algorithm, Cuckoo search algorithm, biogeography-based optimization, and ant-lion optimizer. Therefore, the Cuckoo search algorithm with multi-objective using weighted sum is designed and implemented to identify the optimal network reconfiguration and satisfy the voltage profile to minimize power loss. The network reconfiguration is a process of changing topology switches between sectionalizing switch and tie-line switch. The two switches are used with different conditions. One is normally closed and the other is normally open. These switches are operated in opposite position when the system needs to achieve the objective function. The voltage profile improvement and loss minimization are normally used as the objective for the network reconfiguration purposes. The changes of voltage profile are influenced to variation of load demand, length of system conductor, and performance of load. These changes impact the power loss value in the distribution system. The proposed method will be tested on the I69 bar system, whereas this system has 68 switches which they are normally in closed position. 5 tie-line were added and located on branch from tie-line 1 until tie-line 5 as shown in figure 1, and the tie-line data are presented in table 1. Selected 7 sectionalizing switches need to be opened in each loop if the selected timeline is in closed position. Table 1 is the timeline data and sectionalizing switch data, where timeline 1 is located between bus 8 and bus 43 with one sectionalizing switch. Timeline 2 located between bus 16 and 46 with one sectionalizing switch. Timeline 3 is located between bus 12 and bus 21 having one sectionalizing switch. Timeline 4 and timeline 4 having located between bus 50 and 59 having two sectionalizing switches, and timeline 5 located between bus 27 and 65 having two sectionalizing switches. The parameter of IEEE 69 bus test system is, as base we use 100 megawatt, real power 3.8 megawatt, reactive power 2.6 megawatt, and voltage is 12.66 kilovolt. Cuckoo search is the CSA is a cuckoo birds react as parasitic nature during breeding process. The advantage of the host birds is taken for cuckoo birds lay their eggs on the host bird's nest and the eggs will hatch by the host bird. The host birds will either abandon the foreign eggs or leave the nest entirely to build a new nest when they realize there are foreign eggs in the nest. The standard C of cuckoo search algorithm has three following ideal rules. Each bird in the nest is representing the solution, but each cuckoo egg is representing the new solution. The current solution is discarded by the new solution is presented. Rule number 1. Each egg is produced by one cuckoo bird at a time and one nest is randomly selected. Rule number 2. The next generation is retained from the best nest and high quality eggs has been chosen. Rule number 3. The total number of available nests is fixed and probability of host bird discovering foreign egg. The figure 2 is shows the flow chart process of multi-objective cuckoo search algorithm. The cuckoo search algorithm also implement levy flights to enhance the searching algorithm capability. Levy flight is commonly integrated in it can be expressed as equation 1, where alpha greater than 0 is normally step size stays within the limit of the space problem searching. From the levy flight, the next solution is almost like the previous solution, then the solution won't be recognized. In that case, it needs the different solution. For weighted sum, the issue is to the general multi-objective function is presented as equation 3 and 4, where k is the number of objective function and m is number of inequality constraints. The weight can be set is as summation of weight equal to 1, whereas the combination of the objective function by using this weighted sum, there is no need to add up the values of the weight other than the weight more than and equal to 0. To consider the problem with two unconstrained objective function as shown in equation 5. The proposed method was tested on IEEE 69 bus system and the result is compared to the result from Ants Lion Optimizer technique, and table 3 shows the voltage profile and losses after network reconfiguration process comparing between two different methods, ALO and multi-objective cuckoo search algorithm. The voltage profile using multi-objective cuckoo search algorithm method giving consistently improvement for every different load factor, rather than ALO does not giving the consistently improvement with the same criteria of load profile. ALO method with load profile 1.2, 1.4 and 1.8 there is nothing improvement of voltage profile since the percentage is negative value and become worse in the network system. It is not fit of doing the network reconfiguration if the customer facing the voltage profile lower than initial stage and affecting safety of equipment. Each of method produce the improvement of losses with different load profile. The difference between these two methods, multi-objective Cuckoo search algorithm having high percentage of loss reduction comparing to ALO method with 5 different load factor except load profile equal to 1.2. Figure 3 and Figure 4 illustrate the comparison between initial ALO and multi-objective Cuckoo search algorithm, and it shows that the multi-objective Cuckoo search algorithm has lower losses compared to ALO for load factor 1.4, 1.6, 1.8 and 2.0, while the voltage performance shows for the load factor 1.0, 1.2, 1.4, 1.8 and 2.0 recognize the multi-objective Cuckoo search algorithm is better than ALO. Table 4 and Table 5 indicate that the number of switching involved with different of loads and methods. By changes of load, it affects the topology structure in order to obtain the improvement of voltage profile and minimum power loss. This result shows the number of switching operation for multi-objective Cuckoo search algorithm is lower than ALO even the load factor increases. The low number of switching sequence during network reconfiguration process can help the system operator to make fast decision for actual application. By minimum number of sequence, the transition produced during changes of topology switch will be reduced. Table 6 shows the comparison between initial and other methods, which is involve the open switch, P-loss and Vmin criteria as a prospect of the comparison. For the P-loss criteria, multi-objective Cuckoo search algorithm is 6.4% below of other methods, while Vmin using multi-objective Cuckoo search algorithm is 3.7% improved as compared to other methods is maximum to 4.4% improved. From the result, it still shows the multi-objective Cuckoo search algorithm can reduce the power loss and improve the voltage profile as compared to the initial stage. For load factor 1.0, multi-objective Cuckoo search algorithm is fast converged at iteration 4 comparing to ALO at iteration 55. For load factor 1.2, multi-objective Cuckoo search algorithm is fast converged at iteration 2 comparing to ALO at iteration 20. Load factor 1.4, multi-objective Cuckoo search algorithm is fast converged at iteration 10 comparing to ALO at iteration 20. For load factor 1.6, multi-objective Cuckoo search algorithm is fast converged at iteration 2 comparing to ALO at iteration 8. For load factor 1.8, multi-objective Cuckoo search algorithm is fast converged at iteration 8 comparing to ALO at iteration 30. Finally, load factor 2.0, multi-objective Cuckoo search algorithm is fast converged at iteration 10 comparing to ALO at iteration 6. This paper, the multi-objective Cuckoo search algorithm has been presented to determine the optimal network reconfiguration of the distribution system with multi-objective by considering both improvement voltage profile and minimize power loss. In design, the percentage of voltage profile is higher than the percentage of power loss in weighted sum operation. This is because in the real system, the voltage profile is considering the primary criteria for doing the network reconfiguration, and by doing this, the secondary criteria, namely as power loss, will be reduced after the network reconfiguration done. Another result shows that the number of switching involved for multi-objective Cuckoo search algorithm is lesser than ALO by considering the load increase starting from 1.0 until 2.0. Finally, it can be concluded the multi-objective Cuckoo search algorithm has been successfully implemented to solve the network configuration for improving the distribution system performance, focusing on voltage profile and power loss. This is my reference. Thank you.